Alright, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. It's a Monday morning and time to start a new project. This is a Sansui AU-6900. This is a client unit. A friend of mine, James, brought this to me. He bought this. It's kind of like a treat to himself. I really like this amplifier. I'm really blown away by the looks of this. The more I look at it, the more I like it. The black with the what is it, kind of like a tan lettering. It's etched into the aluminum, and then it's got these beautiful knobs that sparkle. It looks really good. I like it. So anyways, he bought this as he wanted a Sansui as his main driver, and he got it. I think he's got himself a nice amplifier here. This amp came to him. It was previously serviced. He bought it off a gent, and it said it was previously serviced. It has service stickers on both sides, it seems, right here and here. Tamper's stickers. And but he's not completely happy with its performance. It's been serviced, but it's got issues. And yesterday I connected it up and tried it out for the day. And I gotta say, in the morning I wasn't impressed. But then as the day went on, it sounded better and better, and by the afternoon it was sounding fantastic. This thing sat here for 5 weeks waiting for the bench. So that period of time, the 5 weeks, the caps, they deform, or whatever you want to call it, and they kind of fall out of form. And but listening to it for that one day brought it back, which is kind of what I've experienced and a lot of different pieces of equipment that I pull out of storage and pull them out, try them. They don't sound good to begin with, and then they get better and better as you listen. But this one has problems. Overall, it's pretty good. It sounded fantastic, like I said, in the afternoon, but it had a bad channel imbalance from left to right. I was listening to it, and the left channel dropped out and went quiet. And then to compensate that, I had to turn the balance knob to about the 1030 position to bring it back, and then both channels were there and they both sounded good. Now when it did that, I hit mono and that channel came back instantly. So that tells me there's a fault somewhere in that left channel before the mode switch. So when I put it in stereo, the channel would drop out. Put it in mono, it would come back. And then I'd have to adjust it with the balance pot to make it level. Now, the next day, I was listening to it in the morning, and the channel was low, the balance pot was at 1030, and then all of a sudden I heard the channel come back up again, and it was louder, so I went back to 0, and it was balanced again. So there is a problem in that circuit, the left channel, and we'll get into that in a bit. Speaker switch is dirty, a little crackly here. I think it just needs a clean. The volume pot's scratchy and crunchy. It needs a clean. I think the treble pot is bad too. You can cut out the tone controls and that goes away, but when you're listening to tone controls, this can be problematic. Okay. And then I was listening to it, and the LED started blinking at me. I thought maybe aliens took it over and they were trying to message me something. It was blinking on and off. I don't know what's up with the LED lamp, so we're going to either replace that or figure out what's going on with that. That said, that's all it really needs. And I don't know if it's worth hooking up and testing it at this point, because right now the left channel is working. I suppose we could do that. We could hook it up and feed some signals through it and see how it performs. It is a great sounding amplifier, and I love the package. I'm not fond of the dust shelf here in the back that collects the dust, because that's all it's going to do is collect dust and get dirty. But for whatever reason, Sansui does do this. So let's have a look at it. It has speaker switch for 2 sets of speakers, bass, mid-range, treble, and we have a defeat switch here. Tone selector, we can set the the hinge of the tone controls at 600 hertz or 300 hertz, which is kind of high in my opinion. I like it down low. I want it down low as far as you can go, right? And then treble is at 2 kilohertz and 4 kilohertz, which is, to me, that's still in the mid-range. I don't know why they chose those values. Don't know. We have a low filter, high filter, a loudness, minus 20 dB muting, and then our stereo mono switch. Volume and coaxial balance control. This is our tape function switch, which gives you all your options for tape monitor, copying, dubbing, and then our input selector, 2 phonos, 2 auxiliaries, and 1 tuner input. These switches actually weren't giving me any troubles. I was playing with them, but for whatever reason, we're going to figure that one out. On the back, we have our inputs: phono 1, phono 2, tuner, auxiliary 1, auxiliary 2. These are all inputs. These are all our tape loops. It does have preamp out, main amp in, and with a switch to separate or connect the two. 3 courtesy outlets, 2 speaker outputs, and a power cord, no fusing. We do have a DIN connector for tape 1. Phono 1 has a pickup loading, 30K, 50K, or 100K ohms. So you would select this one. I think you would just connect your turntable up and select the one which makes it sound best for you. I don't think there's any magic behind this other than just how it sounds. Some strip screws here. A lot of strip screws. Somebody had problems with their screwdriver. And then all our power devices down here. I like this concept of getting the heat sinking out of the cabinet and out in the open so that this stays cool. Let the heat go wherever it wants. But I'm not a big fan of this shelf here that, you know, all it's going to do is attract dust and get dirty. But can't have everything, I guess. So I turned my scope on this morning. This piece of shit scope's doing this now. I don't know how to turn it off. This is what annoys me with this thing. It thinks it knows better what I want than myself. So let me fight with this piece of garbage here, and then I'll get back to you. Alright, disaster averted. I think I got the scope sorted out. Unless somebody from Rigel wants to get a hold of me and discuss this, we'll talk. But until then, I do not endorse them. So, let's turn this thing on. I don't have it plugged in yet. So flustered here. Okay, let's plug this in. Yeah, it's nice. Click. It consumes about 30 watts at idle, which is nice. It's a nice value to have for an amp this size. And we have auxiliary 1. I got my tone going, so we should have... Yes, we do. I just have to turn this. Okay. Why we got such a flaky triggering on our flaky scope. Okay, let's turn some of this. Defeat. Okay, that. There we go. That's better. So you can see that right channel, the blue, it's got a scratchy volume pot. Let's do this and this. Yeah, it's quite scratchy. So we have to deal with that volume pot for sure. Now, if I think we're having a little problem here with our imbalance. You can see it right here. It's a little bit, the left channel is a little quieter than the right. This volume pot feels loose too, like there's something. You definitely see there is a imbalance between the two. Not severe though. So let's move this back up. Okay. Let's try the tone controls. Okay, bass cut. Mid-range. Seems to be working good. Treble. So you see that noisy treble pot there. Noisy treble pot. Mid-range. A little bit noisy too. It's not as bad. Bass is okay. It's, well, hard to say. Balance. Why did that not see? Balance knocks the volume down too. Turning it up. You see it changes the volume. I seem to remember he mentioned something about this too, the volume balance pot combination. They're interacting with each other. Like when you manipulate the balance, it shouldn't knock the volume down or up. So something's going on with this. For sure, for sure. Okay, let's try. See, now we have an imbalance again. See, the right channel's stronger. The left channel's falling off the edge. Is that a dirty switch? That's a dirty switch. That's the high filter. So I think you get the idea. All the switches are messed up. It's our mute. This is our stereo mono. But when I was manipulating the stereo mono, I noticed a definite difference in the levels between the two channels. When you hit it in mono, they both came alive. But this here, it's not working. Okay, so tape monitor. And the function switch seems okay. Let me try different inputs. Let's try tuner. Seems okay. Let's try auxiliary 2. Auxiliary 2 is kind of flaky. Let's try tape monitor 1. Okay, let's try tape monitor 2. Alright, you know what I think I'm going to try here? I'm going to put this back on auxiliary 1. And I'm going to try this switch at the back here. I'll wiggle it a bit. That switch seems okay. Speaker switch is a little dirty. That could be the cause of it right here, is a speaker switch. See how it goes distorted and low? We still have an imbalance though between the channels. That's what I can't. Alright, I think I've seen enough. So have you. Alright, here's a block diagram for the AU-5900, 6900, 7900. So the only difference here between the three is the tone control section. So this is the 5900 here, this is the 6900 here, 7900 here. So it's a little bit good, better, best. Think of it that way. So I was experiencing, here's our mode switch right here. And here's a connection to the right channel. So a mode switch, all it does is it shorts your left and right channel together and combines the two signals into one. And when you click it on to create mono signal, that's all it's doing, is shorting the two channels together. So I was experiencing the problem before this switch. So everything here is suspect. So that's our tape monitor switch and our function switch. I didn't test out phono, but I was feeding an auxiliary signal in. So it's only going through two switches before it hits the mode switch. So when I clicked it, I had the channel drop. It was a significant drop too. It was quite, like I said, I had to turn the balance control to about the 10-30 position to get it to balance. And it sounded good in that balanced position once I balanced it. But so we have something in here. There's no active circuitry between the input and this mode switch, which tells me it's all either connectors, wiring, printed circuit board joints, switch contacts that, you know, where the failure could be. So we have this is our area of focus right here. So we're going to focus on these two switches. I happen to think it's one of these two switches, or maybe both. How do we test for it? Well, we could do one of a few things. We could connect an ohm meter between this point here in the circuit and our inputs, and then when we switch our inputs to, we should be able to do a resistance check through this. There should be no active components in here. There should be no blocking capacitors, no resistors. It should be just a straight shot in. So we can test for series resistance between each input and this mode switch. And if I go through and test left and right channels on both of these, I'll bet you I'll find some of them are really high in resistance. That's where our problem's going to be. Looks like we're going to have a security breach on our hands. Not once, but twice. Now look at this. It's got loose screws. That one's loose. That one's tight. This one's not even the right color. It should be black. This one's loose. This one's loose down here. You can see it. Loose screws everywhere. I don't know. 1, 2, 3, 4 loose screws. This is not even the correct screw. Oh boy. What am I going to get myself into here? Alright. So one screw left. Yeah, they were all loose and they were mismatched screws. I don't know who worked on this, but I usually try to make sure at least the screws all match. Good amount of dust. Somebody's been in here, but they didn't clean it. And it looks like they replaced capacitors. These are all the gold Nichicon. Gold Nichicons. Looks good. Looks good. When they did a recap, they didn't clean the board. They just left the old glue. So I might clean some of that up. It's got all the original transistors. Looks like we have original silicon here. I don't think any of these have been replaced. They all look matching and original. So, if it was serviced, looks like they might have replaced the main filter caps though, because that doesn't look, it's got the PC mount with the 5 pins, and then they just tacked wires on to the pins. A little bit loose there, that's loosey-goosey. Things are flopping around. Alright, we'll have to secure that. Some You can see the dust on the inside from convection currents. Yeah, look at this thing. Dusty inside. And then we do have a continuation of the recapping up here too. So somebody did work on this and replace caps. This board as well. I don't see any new silicon. Not that that matters. Some people like to replace all the transistors because they're getting like 50 years old. I don't know. I have reservations on doing that. If it's working, why replace it? I don't understand. Yeah, it could fail, but then everything else could fail too. So where do you stop replacing parts and start enjoying it for what it is? So these are our switches. We're gonna have to take these out and clean them. It doesn't look like anybody's cleaned them. They might have just sprayed them. Doesn't even look like it's been sprayed because all the dust around it. You'd think the dust would get a stain on it. Well, we're going to fix this up for James. We're going to make this a keeper for sure. First thing I want to do is those resistance checks between the mode switch and the inputs. And we're going to see where we're getting our high resistance. So let me do that. I'm going to do it on camera because it might take a while. Got a 6 amp fuse. What do we have? 6 amps. That's good. Ooh. Yeah, that's not cool. I just touched that and it fell down through the bottom. Alright. Somebody put 15,000 microfarad 80 volt DC caps in here. Rated at 105 degrees. These are CDM. That's who's CDM again? Can't remember. Okay, I was wrong. So these are inputs, phono up here, tuner, auxiliary. If I follow the tuner through, goes up here through the switching, function switch, tape monitor switch, and then it goes in, and then there's a 10K resistor here. That's why I was measuring 10K when I connected up my meter. So I'm going to have to connect up before this 10K on pin 31 and 32. And that should give me a clean resistance reading through these switches to see where the problem lies. Okay, I hope you can see this. This is my measurements I took. So I measured from these 3 inputs, tuner, auxiliary 2, and then I measured tape 1 and tape 2. Okay, so there's 5 inputs I measured. These are all inputs, and I didn't do the phono yet. I might do the phone. Yeah, well, I'll think about doing the phono as well. I took measurements from these 2 wires here. This one here and this one here. This is the input from the back panel board. This is the input from the function switch, tape monitor switch, right on these 2. So between those 2 points, this left and right channel, and these connectors. So this is what I'm measuring. So overall, right channel was not bad. I measured 600 milliohms, 400 milliohms, 500 milliohms, so in the half ohm range for these 3. Tape monitor 1, I measured 495 milliohms and 1.5 ohms on the other 2. This is just right channel. Left channel is a bad thing here. We got 6.5 ohms, 10 ohms, 22 ohms on these 3 inputs. And then on the tape monitors, I got 187 milliohms and 315 milliohms. So these are okay. So it looks like a problem lies within the function switch and the left channel only. Now we might have, these are wafer switches, so we might have a loose rivet, a cracked solder, oxidized joint or oxidized connection. So we're going to have to go through and figure out what's going on. So even though it looked clean when I was using it, you see the dirt on this doesn't look the greatest. So that'll clean up nice. Yeah. Okay, right off the bat, I'm not loving this design choice that Sansui made of this back panel thing. But you have to disassemble everything to get it apart. And a ground wire on this side. Try getting this off. Ugh, what a crappy design. Now I can actually access the board. I'll take this board out. I can do that, but some have connectors, some don't. I don't understand that. Why don't they just make it all connectors? And then to get to the main power amplifier, you got to disassemble it. Like the person that did the recapping on this, yeah, it's just not very service friendly, let me tell you. So I got to disassemble all this. At least the heatsink is still secured. All right, I got the main, well, it's not the main board. This is the input board. It has all the input and output connectors, DIN connectors, the switch for the main preamp output. It's got our phono section here, and a little power supply for the phono section. It's got its own power supply. It's all been recapped with either the Nichicon Fine Gold, these are FWs, and these are the Muse caps, these are the bipolar caps, the green ones. So everything looks good here. I did notice a couple things. This black wire was not attached to anything. This is a ground wire for something in here, and it was, I think the previous tech, when he took this board out to do the recap, they forgot to reconnect that wire. It was kind of hidden in the back there, so it could be easily missed, but it wasn't connected. Everything else was good. Now, they use these FW Nichicons in this power supply. These are audio grade caps. They're really not useful for power supply filtering. They're 85C rated caps, which means they don't stand the heat very well. They're better as a coupling cap than a bypass capacitor, in my opinion. There's better choices they could use in this power supply than these gold ones. If you want to put these in audio circuits, that's fine. Put them in there, down in here where there's no heat. But looking at these two here, I actually found a couple. These are 47s at 63 volts. Let's test these and see how they're holding out. I don't know how long these caps have been in place. So let's see here. This is a 47 at 63 volts. We're down to 39.6 microfarad on that one. 39.3 microfarad on that one. So those two, I'm probably going to yank all these caps here and replace them with better caps. This is a 4.7 at 100 volts. I can't even get this one to register. That's odd. Try it here. And nothing. Maybe that cap is open. This one here, this measures 3 microfarad. And what is it supposed to be? It's supposed to be a 3.3. So that one's okay. This one here is a little far off the path. It's a 10 microfarad at 63 volts. Whoever did the recapping, they put in the highest voltage caps they have. 10 microfarad. We're down to 8.7. Not terrible, but not great. This one here is a 100 at 63. This is obviously a power supply filter cap. Down to 90, and this one's a 220. Down to 185. So you see what I mean? These caps aren't the greatest choice for that circuit. But that's what it is. So I'll probably end up replacing some of these, not all of them. These here, I'll test these and see if they're okay. If they are, I'll leave them alone. These switches look quite dirty, so I'm going to remove those next. Just desolder them, take them out. I'm going to clean them. I'm going to give them the full treatment. I don't want to see any contact resistance. I could actually measure now that I have the board out. I can measure between there and these are our output lines, and could do that. Another thing you could do is you could set up with a power supply. You could set up a current that runs from one of the inputs, left or right, to the outputs and feed a current through all your switches and your wires. And it doesn't have to be a high current, something like 5 or 10 milliamps. You use a resistor, a current limiting resistor, and you put about 5 or 10 milliamps through these lines. And then with the voltmeter, you can measure at each point where your voltage drop is. And when you find your voltage drop, you know that's your problem. You can go in and clean it, or resolder it, or do whatever. I might do that off camera. I don't think I'm going to need to, though. If I clean these switches, put them back in, I have a feeling this is going to be less than half an ohm series resistance, and that's probably going to be mostly in the resistance of the wiring and the copper traces. Contacts, well, they add resistance too, but if it's nice and clean, it shouldn't be a problem. So we got a 2SB 526, 2SD 356 as our regulator pair there. Looks like we have Zener's. I think that's a Zener, I'm not sure. D11. Anyways, somebody's been here working on this. All these connections, some of them are cracked, so the tech went in and added jumper wires. You can see there's copper traces missing and so forth. So I don't know what kind of problems he had that he had to do all this, but I think it's solved, so I'm not going to touch any of this. I'll probably clean it up a little bit, but and I'll give it a good clean, get rid of all the flux, and give it a good inspection and make sure. Look at that. What is going on there? You see that blob of solder got squashed? I wonder what squashed that. Oh, there's a strut here. That's right. There's a plastic strut. A plastic strut that goes down along here. So maybe that got... I'll have to clean that up. Other than that, everything looks good. I don't see any cracks in the joints yet. But I always give it a good cleaning before I inspect it, because it's really difficult to see cracked joints when it's all blobbed with flux. Okay, I'm going to get started to remove these 4 switches, and then I'll give them a clean, and then I'll bring you back in and let you know how it went. Alright, I got the switches removed. Both of these are out. I'll service these independently. Now I'm going to focus on this board. I'm going to scrub this board now. Look at the dirt and filth that's in it. I'm going to give this a scrub, and then I'm going to scrutinize this. I'm going to probably replace some of these caps, since they're already weak and failing, with something more appropriate. And then I'll check over this phono stage here just to make sure everything's kosher. And these inputs I'll probably end up cleaning with a pipe cleaner, because I do have access through the holes. I can clean out all of the contacts on the inside as well as the outside. I can polish if I'm so inclined, and I'll get this ready to go. And once I clean and service these switches, they'll get soldered back on. And back gets a clean, and it'll be ready to be reinstalled. Okay, so this is necessary, disassemble and cleaning. So I cleaned this wafer, took it apart, cleaned it with 401B, and after I finished cleaning, I treated it with deoxide DL100. Now, I did some continuity checks on some of these contacts with, testing it as I turned it, getting about 50 milliohms on each contact, and then when I had about 300-400 milliohms. So what I did is I just soldered it, this rivet here, just cleaned it off, fluxed it, and soldered it. And now I'm back down to about 50 milliohms on that contact as well. So that's necessary, because that one joint was bad. Now, time to do the other side. So what I do is I position, these are 2 wafers are identical. So I'm just going to position this one the same as the other one. You know, if you can see the difference between the two. It's quite dirty. Let me pull this one off here. Let me see if I can do this on camera. It's quite dirty, these switches. I don't think anybody's treated them before. Come on. Okay. And you can see how some kind of residue on there. Quite dirty too. So I'll do the same treatment, clean this wafer up, treat it with deoxit, and then test for contact resistance. Any problems, I'll go after these rivets and resolder them, and then the switch will be done. Alright, just finished the switches. The tape monitor switch is actually in a lot better shape than the function switch. I couldn't get good low ohms resistance readings on any of the functions, so I had to end up soldering a lot of the contacts got soldered down to reduce that. The rivets are going loose on this. That's what the problem is. Alright, so here's the board done, except for I haven't cleaned the sockets yet. I'm going to do that next. I'm going to use pipe cleaner. I'm still sitting on the fence what cleaner I should use with the pipe cleaner. I want to get something in there that's going to get the dirt out, but I don't want to. Yeah, I don't know. I'll think about it. And you got to be careful with these because they leave fibers behind. So you got to maybe go follow up with compressed air and blow out the holes, get the fibers out, and yeah. So everything's done here. I replaced these caps. They weren't doing very good here. They were failing already. So I put in some nice, very low ESR caps for this power supply section. I replaced two of the Nichicon Muse caps and put in film. So these are very good for this position right here and here. These other two I left alone. They're doing fine. Clean the board, clean the switches. A lot of problems with this switch. This is the function switch. There's a high resistance in a lot of these connections, so I did a lot of soldering to bring that down. Shouldn't be any more problems. Clean the back. And like I said, the only thing I have to do now is clean each of these RCA connectors, and I'll get started on that. And then this is done, and then I can bring in the next phase of this project. Here's the next phase. Pull the transistors off, repaste everything. I don't see anything on these, very little compound, if anything. I'm going to check a lot of these too. I'm going to clean up some of this board. I'm going to remove these caps and clean up this glue. I don't like seeing that. Clean it up. Why not? We're in here. And then I think I got another problem here. Somebody put a 0.51 ohm resistor in here as this is a emitter resistor. It should be like a 0.47 like the rest of them, but this isn't correct. I'll have to remove this and replace it. It should be 0.47. They should all be the same. We should measure the same. And then aside from that, it's just a matter of cleaning. It's very filthy. And yeah, I haven't seen any troubles on this one yet, but we haven't got into it. So, all right. So I'm going through removing these transistors, and I was looking at the hardware here. So for the most part, the hardware for the TO3 transistors is tight. I was going through and checking some of these. A little bit loose. They have the collector run through the screw, and then the screw is supposed to make contact with the foil on the board. This side of the transistor is insulated. This side is connected to this trace. Same for this transistor. So this one here, that one's tight. That one's tight. That one's tight. That one's tight. So yeah, they're all tight, pretty much. No complaints. But the drivers, these drivers, they have the collector tab is cut off, and then the emitter and base and emitter flow through to the board. So there's two wires going through the board. Right here's our driver transistor. Two connections, base and emitter. And this is loose. The collector tab on all of these is loose. Here's another one. This one's not bad because it's double nutted. This one's loose. This one's loose. So this is a bad thing, having a loose connection on your collector tab of your driver transistor. So what you could do is you put a star washer under here. There's no star washer. The goofy thing is they got solder underneath the pad. And let's see if we can get this out. I have to hold the screw here. Where are we? There we are. Okay. Now there's no star washer here. There should be a star lock washer. And another problem is they have solder on this pad. So it doesn't matter how tight you get it, the solder is going to flow out. It's plastic, right? And it's going to flow out, and then this joint's going to go loose. So I'll have to get some star washers on these transistors. All of them need it. It's just not a big deal. Let's put this back for now. Alright, I got the main board out and I'm starting to work on it. A few things I wanted to talk about. I replaced that one resistor that was not the correct value. Okay, so I got another resistor in there, and then I started checking the other ones, and lo and behold, one of the original resistors was way out of whack. It was not 0.47 anymore, it was 0.56 or more. This one's really been overheated. You can see there's a burn mark and a crack down the middle. I don't know if you can see that crack. And then there's a crack on this side, longitudinal crack. So this one got overheated and its value is compromised, so I replaced that one as well. So I replaced 2 emitter resistors. Now I'm working on capacitors. I am going to change some of these capacitors, especially the ones in the power supply circuit. So C603 is this one here. It's a 47, and I think it even measures bad. Let's try this. 47 microfarad to 50 volts. Come on. Yeah, it's 39 microfarad. That one's a goner. I don't know why. There's really no heat in this area. C606 and 605 is 220s at 63. That's these two. These are really incorrect capacitors for this. This is a power supply filter. And let's see if we can get a reading on one of these. I'm going to do it from the back, maybe. Yeah, this one's not even 187, down from 220. So I'll replace those two as well. And then there's 100 at C607. Where's 607? 607. Doesn't matter. And then there's a couple of 1 microfarad caps here. I'm going to rip them out and put in film caps, because film caps are superior to anything that an electrolytic can do. And then I think I'll be pretty much done here. I'm just going to check some of these fuses. This is supposed to be a 1 amp. And it's a 4 amp. How about that? That's no good. This is a 1 amp here. It's another 4 amp. It does say 1 amp on the board, doesn't it? I'll have to check that in the service manual. But we had 4 amp fuses here. And these are 7 amp, so let's see what these say. 6 amp. That's incorrect. And 6 amp. So we'll have to replace all 4 of those. Replacing 3 or 4 caps up here. A couple of, I'm going to install some films here. Another thing I'm going to do is these transistors, these 5-legged transistors. This is a 2SA798. Everybody on the internet says you have to change these, otherwise they soil themselves. But I'm going to rip these out and put in brand new transistors, even though they're working fine. I don't see any reason to change them, but I'm going to anyway. And then I think that's going to be it. I think everything else is good. The relay's out, going to get serviced. Back's going to get cleaned. Didn't find any cracked solders anywhere. It's just dirty. And clean up the flux. I'm going to have to figure out a solution for these nuts, these collectors on these transistors. Some of them were loose, some of them were tight. the TO-220 transistors, they were all loose, so I have to figure out a solution for that one as well. You definitely don't want a high resistance connection on your collector of your transistor, driver or output device, because that can really mess up your audio and give you high distortion. And then after that, I think we're ready to put this in and move on to the rest of the unit. So I actually did find some cracked solders, and it's these two connectors here. These pin connectors. Nice gold plated, by the way. I don't know if you can see this on the other side here. I don't know if you can see this. Try zooming in. If it'll let me. You see those cracks there. So one on the bottom is the worst. This is a... What is that? I think it is a... I don't know. I'm not sure. But I'm just going to reflow all these joints. Give this another chance. Oh, this one was cracked. This one's definitely cracked. Yeah, we'll get this fixed up. I'm just about done. I'm going to do cleaning now, the back. I think I've done everything I need to do. Replace the select few caps. Replace the long tail pairs. Replaced like a few caps. 1, 2, 3 here. Installed 4 film caps. 2 long tail pairs. Check some resistors, they're all okay. Everything else seems good. I don't see any other things to do on this. So I have to replace those fuses. Okay, I'm going to scrub the back clean and then I'll be done with this one. Alright, so I just finished cleaning the relay. When I tested it before I started, I had 400 milliohms on one side, about 80 milliohms on the other, which is actually not too bad for a relay of this age. And I don't think it's been serviced before. To tell you the truth, I don't think it's been desoldered from the board. So clean the contacts. Now I have, I think I got 10 milliohms on one side and 11 on the other, so which is just perfect. I'm going to put this back in and straighten out these contacts here. Put this back in, solder it in, and I'll be done. I'll be done with the main board. All right, so here's the silicon. These are all originals. These two were replaced previously by some tech. Now this is an outlier here. It's got a gain of 126. This is the 2SB 545A. And this one is more in line with the others. Not that it really matters if you want to have complementary pairs, but they don't have to be matched for output devices. These are the drivers. They're all doing fine. So these had barely any grease. They had that clear grease, and there was barely anything on there. So I'm going to paste them up good so that they don't have any problems transferring heat. And then I'll start putting these back in. Alright, I'm at the point where I could put the semiconductors back in, the power semiconductors, and I got everything cleaned up on the amplifier module. Everything's nice and clean, ready to accept the transistors. So here's our mounting for, let's see, this is our mounting for one transistor. This is our collector tab connection, emitter base, and then this is a floating connection here. You can see how the square nut left an indentation in the board. Now that's from having it tightened up, and then over time the phenolic board is kind of plastic and it relaxes and deforms, and this is why these go loose. So I'm going to propose to do is put down a steel flat washer, small enough that it doesn't short out with the trace, and then it'll help spread that clamping force. And once I get this tightened up, it should be okay. Now for the other connections, I do plan to use star lock washers. Now, star lock washers come in two configurations, internal and external. Here's the difference between the two of them. So this one has the star on the outside. That's what I don't really want. That would work if I used a flat washer on top and then use the nut. But I'm going to use this one here. This is the internal star lock washer. And it's got its teeth are on the inside of the washer. So I could just put one of these over one of these holes here, and then put a screw and nut and then tighten it down. Now another thing I want to do is do some kind of thread locking here. Okay, so let's assemble some of this just to get an idea of what I'm doing here. So I got my first transistor, first location, orientate it the right way, and we'll just feed it from below and get it to go through the board. There we go. Alright, so first off I'm going to secure the end that doesn't have the connection. And these are just M3 screws. Looks like about, what are these, 16 millimeter long? I don't know. So what I'm going to do here is I'm going to use a washer to help spread the force, and then I'm going to use a nut. I could probably reuse the square nuts. Doesn't really matter at this point. Just put this here temporary just to hold that. Hold that down. Alright. On the other side of the transistor, I'm going to use the same hardware. I got this. And then I'm going to drop in an internal star washer for electrical connection. And then I'm going to use something a little different here. I'm going to use a lock washer. These are nylon M3 lock washers. So I can put one of these on, and then once it's torqued down, that should make the connection, and it should keep it tight for indefinitely. I'll have to get a screwdriver and my nut driver. Little tip, most M3 nuts are 5.5 millimeter. So if you get yourself a 5.5 millimeter nut driver for your bench, I think you'll be happy. So this is good for tightening nuts down. So I'll get these installed, and let's have a look and see what it looks like from this side. And so it's going to look like that. I know it's a mess. You can hang it over the table here, hang it over the bench, and then I can come up with a screwdriver from below and tighten this down. Snug it up pretty good. Now that's going to provide a good connection. It's not going to go loose over time. And this other one I can take this and tighten this down too. Snug this one up quite a bit. And that transistor's in place now. Let's have a look and see how it. So that's squished out. That's what you want. So I'll do that for all of these. Do not solder anything until you're done tightening all your transistors and securing them. Because if you solder it now and then you tighten your transistor, you'll pop the foil off the board, right? So just wait till you're done and then do all your soldering later. I'm going to have some extra of these square nuts that came with the receiver or the amplifier. So I'm just going to put these, double nut these. And then when I'm done, I can lock these down, and this will be like a lock washer too when you double nut it. Now for the TO-220 transistors, you can do one of two things. You can just drop the screw through and rely on the screw connection to the tab for your collector. As I said before, these have the collectors cut off, the collector wire cut off, so they're relying on the tab for the connection. So I could just drop a screw through, screw it down and be done. But they provided, Sansui provided these. These are what they have is they have this metal collar inserted into this little plastic thing, and it's just a hold down clamp. There's no harm in using it. I think it's okay. It actually probably works better. It probably spreads the forces down on the transistor more evenly. So we'll use these instead in each location. And just like the TO3 transistors, I'm going to use a star lock washer on each of these TO220s for electrical connection, and then I'm going to use a nylon lock nut on each one too. So there we go with that, and then we tighten that down. That's going to be good. And that'll provide a secure connection. So when you're done installing all the hardware and the transistors, just go through and give them, first actually what you do is you go through and make sure your micro washers are aligned properly, especially on your TO220s, because they can get skewed and go sideways, but these are all in place, so that's good. So then we go through and do a final torque on all of them, just give them the same general torque. Don't go crazy squashing these down, because you're just going to end up crushing the board and causing you problems. So just give them a nice snug, just to make sure you didn't miss one that's loose. Okay. All right, then you go through and you snug up all the other hardware. Now, since I have a bunch of these square nuts left over, I'm going to use them as lock nuts on the existing nuts. Just as a jam nut kind of arrangement. When you put two nuts together and tighten them against each other, they lock. Everything together. If I can get this on. So if I can get another pair of pliers, so what I might just do is tighten this down, and that should not come loose ever. So I'll do that for all of them. And then the last thing you do is you always do this, is check for continuity between your collector tabs and your heatsink. So here I got my heatsink. Check the collector tab of every transistor to make sure you have insulation. And we're good on all of those 12 transistors. Now that everything's tightened down, Sansui had this wire here between this nut, or this bolt, collector terminal, to this collector terminal here. And what this does is it transfers one of the rail voltages to the other side of the board. Get rid of that. These two dots here are positive negative rails, and it comes in this one here. I don't know if it's positive or negative, it doesn't really matter, but it comes in here and it goes to these two collectors, and then it's supposed to jumper over to this pad and then connect to these two collectors on the transistors. That's what this wire did. So I'm just going to add a jumper here instead of having the wire. The other one, the rail voltage comes in this dot, and then it goes over here and connects to these three actually, because it connects with the driver transistor as well. And then it goes through here and connects with this collector, this collector, this collector. And so these three on this side are, so this one doesn't need a jumper, but this side does. Like I said, I'll just jumper a wire across there, these two pads, and then that's the same as this contraption, which worked, but it's clearly unnecessary. So I'll get that. And then the next thing I need to do is solder all the joints, and then this will be done. Alright, got some new fuses here. I got 1 amps. Put these in. I got some 7 amps here. Oh, no, I don't. I only have one. Looks like I have to go do some more shopping. I'll have to hunt down another 7 amp fuse. Oh boy. Okay, so this data actually had a lot of work done to it. A lot, to tell you the truth. Replaced the long tail pairs, replaced a few caps in the power supply section, worked the relay, got the contact resistance down to about 10 milliohms, to replace a couple of emitter resistors. One was wildly out of tolerance, the other one was the wrong value, so I replaced those. I took out some small value electrolytics and put film caps in their place, make it more stable. And did all the cleaning, and everything's done under here. And as a finishing touch, I put a bypass capacitor across the voltage rails just to help with transients. And yeah, I cleaned everything up and it's ready to go back in once I find that fuse. Alright, so I'm going to move on to the rest of the unit now. Okay, with that out of the way, I'm going to move to the chassis now and start working on the rest of this. I have a lot to do, and I'm finding more and more as I look. Now, have a look at this. This is probably my fault from just manipulating wires and stuff, but this here is already broken. This is the start ground connection for these caps. And the way the tech did this is he just laid a wire across and tacked them together, kind of didn't even really get the joint hot. You just kind of tacked it and used the solder as glue. But you need to have a mechanical connection here before you solder it. Otherwise, you're going to get this. And this is bad because this is our negative filter cap for the negative rail. No, this is our ground connection. This is our negative right here. Sorry. Yeah, so I'm going to spend some time rebuild all this. And then another thing I'm going to do is I'm going to secure these down. I have some sticky sided foam tape that I can use. I'm going to wrap these caps, and then this will grip and it won't be sliding around like this anymore. I'll make sure that this is solid and secure, and then we can move on to other stuff. Other stuff being, you can go through the tone amps. I'm already looking at the tone amps here and I'm seeing transistors, 2SC1313s, those are on the naughty list. 2SA726 or 720, yeah, 726, that's another one. So I might be replacing some of these transistors, even though they're working fine. And then I'm going to do a pot clean, switch clean, and then hopefully that'll be the end of it. So this is what we got here. We have a little bit of foam tape that's crushed on this side. This side the foam tape fell out. I don't know if that's the cause of why this is so loose. Shouldn't be. Well, I think these caps are not the originals. They're maybe slightly less diameter. They're nice caps though. They're 15,000 microfarad, 80 volts, 105C. But the installation kind of failed on the execution there. So yeah, I'll secure these caps, and I'm also going to fix this all up. This is not cool here. This tacking wires on. You should have had these wrapped and soldered instead of just tacked on like this. So I'll clean all this up, and yeah, that's not good. And cut off the fifth lug here that's not being used. It's a dead lug, so just cut it off. It's in the way. Well, there you have it. I opted to do a little different than what it was because they had the ground running over top, connecting outside to outside, and I saw that as a potential short circuit hazard because we had our rail voltages inside here. So I elected to just reverse that, put the star ground in the center, put our rail voltages on the outside, and then that way it's less chance of shorting out. And these are all secure. Actually, when I was desoldering all this, the previous tech didn't get enough heat on these wires, and only one of the wires had solder that flowed through the strands. The other one was just completely unsoldered, and I don't know how it made connection, but it did. So what I did is I had 14 gauge solid copper, and I wrapped it around these pins and crimped it with a pair of needle nose so it's mechanically secure, then soldered it, and that's my basis point for wrapping the wires around and soldering that. And then I did the same on all four of these posts, or 8 of these posts. And then this here I cut up and bent to wrap around the star ground. And that's secure now. The caps are in place and they're locked in. So this is all good now. I gotta say, I'm not loving this design. They have this layout of the back panel with this shelf. When you have any work to do on the main power amplifier, you got to remove the whole assembly, which means disassembly of all this. And it just wasn't well thought out. I think they would have been better if they had a back panel that was flat and straight up and down. The only advantage to this is your heat sinks outside the cabinet and everything inside stays cool. But from a service point of view, it adds a lot of time and unnecessary steps to a tech's day and just to work on this thing. So what we're looking at here, this is the speaker selector switch. It's got, let's see, this one here is our signal in from the amplifier. Then it goes A and then B, and then A, B both. It has this one channel here, one channel here. So this switch was flaky when I tested the amplifier. You give it a little wiggle and you get a channel cut out. Now this side hasn't been touched. If I flip this over, I hope you can see this. Be careful not to break any wires. This side's been cleaned and over cleaned actually, to the point where they've removed the silver and we're down to brass plate, which isn't good. Brass won't conduct as well as silver and it will be noisier. So I'll give this side a clean the best I can, and I'll clean both sides actually best I can. We'll see if we can clear this up. The contact resistance on this was about 200, well, it was jumping all over the place, but it was between 2 and 400 milliohms. And this was probably, the other channel's the same. Now I'm going to try and clean this up. Ideally you want contact resistance down below 50 milliohms. 25 would be better. But these wafer switches are pretty lame when it comes to contact resistance, so you got to take what you get. But we'll clean this up and we'll see if it improves, and it can only get better than what it is now, so I'll do that. Alright, so I think I've done everything here in the front end. Cleaned the speaker switch. Actually, it turned out really well. I was impressed. I'm down to about 8 milliohms on all of the 4 contacts for the speakers, and that's good. I tested the power switch. Power switch is healthy. If it's got spare contacts, if it wasn't, I could swap the wires over to the other side, but I don't need to. I didn't touch any of these switches. These switches all tested fine initially. I cleaned these 4 pots and I replaced 10 transistors on this tone board, 4 capacitors, and then cleaned everything up, and now it's just a matter of reassembly, and then we'll get on with our testing. Alright, so we're all back together. I have checked it over, and I think we're okay. All the little wires went back to where they came from. So let's do our first initial power up and see how this goes without any sparks or bangs. Oh, relay click. And we're down at 14.5 watts. Now, let's see if we have signal. We don't have any signal. Why don't I have a signal? I need to figure out why we got no signal. Speaker A. Try speaker B. Nothing. Wow, we have to figure out why we got no signal. Alright, so I'm back, and I had a little upset here. I had powered it up. I had no audio through the amplifier whatsoever. Couldn't figure it out. I ripped the front panel apart again, and I did some tracing. And it was a good thing too, I took this all apart because I discovered a lifted pad, broken trace on one of the channels, so I would have had no audio on one of the channels. But that's been fixed. But the problem with the no audio going through to the power amplifier is, I don't know if you see this, all these brown and orange wires running everywhere. Everywhere is a brown and orange wire. And I got 2 sets of brown and orange wires mixed up, and I had these ones, which is a power feed to the amplifier, connected to the input board, which connects it to the main and preamp out connectors. And then I had this one connected to the B plus feeds, and that's why it wasn't working. I just had no power going to the power amplifier. Didn't do any damage by feeding power into the outputs, and it's a good thing too. But anyways, live and learn. So I do have it set up for doing a bias test. We're going to get the bias here going. I need to turn down the volume, and let's turn this on. And our target is 18 milliamps. So right now we're consuming about 32 watts, 33, and I think it stays pretty stable around 33. But I'm going to get this dialed in. There's two adjustments, one here and one here for each channel. I'm going to do this one first. They say minimum 3 minutes, let it warm up. I'm going to let it warm up for a while, and we'll see if this is supposed to be 18 millivolts. And if it isn't, I'm going to adjust it till it is, and then I'll get on to the other channel, and then we'll do our power test. Alright, this thing's been idling for about half an hour, and it just slightly crept up. This side was actually set to about 80 millivolts. This side was pretty much bang on, so this side was over biased and was sucking too much current. So I turned it down, but it's still, give it a little bit more, and then we'll give it a final test on the other channel. If I can remember where to hook this up, I think it's here and here. Yeah. And this one crept up a little bit too, so I'll turn this one back down. Turn to about 17. And our consumption has also dropped to about 24 watts, which is perfect. Alright, let's do some testing. So instead of replacing the LED, I noticed it was quite heavily oxidized. So I just took a Scotch-Brite pad and cleaned off the leads. We're going to plug it back in and see if it behaves. If I still get a flickering LED, I'll still have to replace it. But there's no reason why it should flash anymore. Alright, so I got it all dressed up again, looking good. Look at how nice that is. And we're all wired in for a power test. Let's do this. Let's turn this thing on. 40 volts plus and minus on the rails. I think that equates to about 60 watts. I'm not sure. But let's see what this thing can do. So let's turn this on. Turn on my signal source first. Get that going. Okay, I think I can turn this on now. Relay clicked. And I think we're ready to go. I think we already have a signal on screen. Let's turn this thing up. There's our clipping. Now I'm taking off the top trace, which is the left channel, right about here. Let's go to clipping. And let's back it off right about there. I'll take that as a peak right there, and we have 23.15 volts RMS. Start our timer. Let's come back in 10 minutes and see how this goes. So for right now we're consuming 232 watts. 233 or thereabouts. So we are coming up to the 10-minute mark, and I'm pretty impressed with this amplifier. The heatsink isn't even heating up. It's like 40 degrees, well 35, 40 degrees on this side. Yeah, it's barely warm. It's like, I don't know. It's actually running really cool. 39 degrees, 36, 35. Yeah, I think this is doing really well. The power output did drop a little bit over time. We're down, oh, what are we at now? 22.99 volts RMS. and our power consumption also dropped by about 4 watts. Now I happen to think that's because the rectifier diodes heat up. When they heat up and they get hot, they become less efficient, and they're not transferring the same amount of power as they were when they were cold. So that's why I think it dials back a bit. My load, on the other hand, is quite warm, so let's turn this down. Let's turn up our resolution on our scope, and let's go for about 1 watt. There's 1 watt there. Let's go for a square wave. Okay, let's go a little more. Alright, there's 1 kilohertz square wave. So let's test out the speaker switch here. It was flaky before, now it's clean. This is our tone controls in. This is bass. It's all looking good. Mid-range. And treble. Oh, still a little scratchy on the treble. Okay, tone controls out. Now let's see here. This is our 600 hertz, 300. Let's try 300 hertz here. Switch is a little dirty. Let's see here. This is treble, 4 kilohertz. Low filter and high filter. Okay, this is loudness, pretty typical, and then our mute. I didn't touch the switches in this thing. They're a little bit noisy, but I think they're going to be okay. Is this a stereo mono? Okay. Balance. It's their tape monitor switch. It's fairly clean. It's all looking good. Alright, so here's a look at some of the parts that went into it. We had 4 fuses, incorrect values, so we replaced those, pulled those out and replaced them. I replaced 20 transistors, both long tail pairs. Here are these 2SA798s, and then the rest of these. All these tested fine. There's no problem with these transistors whatsoever, but they are on the list, and they can develop problems sometime in the future. They may or may not, I don't know. They might work good forever, and they might start failing one at a time. But I did test them all, and they all test 100%. So make that what you will. I put new transistors in. 2 emitter resistors. One was the incorrect value they put in, and the other one was totally out of whack. It got overheated. It's got a big crack down the side, and it doesn't measure its value anymore. It's out of tolerance, so those 2 got replaced. Got some caps here, some fine gold Nichicons. These are already starting to fail. They were used in some areas, power supplies, where they get a lot of heat, and some of these are already failed. For example, if I take this one here, this is a 100 microfarad, 35 volts. Measure it. It measures 81.5 microfarad 400 milliohms ESR. So that's starting to show its age already, even though these caps are not that old. I think the date code is 2015. Date code on this one is, no, that's 2016 on that one. Date code on this one can't be 2021 already. That's a fairly brand new cap. 2020. Wow. So yeah, but then these gold Nichicons, they're not endurance caps. They're an audio cap that you put in a circuit, and you got to treat them with kit gloves. You got to make sure they don't get too hot, and you know, all that stuff. And they're treated well. But these ones, they're not intended for power supply use. So I yanked some of them out. I left some of them in, and I yanked some of them out. So that's as far as that goes. Alright, so this one's done. I'm going to put this on a listening bench. Let's give it a couple weeks, just to make sure there's no nagging little problems. And it sounds good. I have expecting it's going to sound better than when it came in. It always sounded pretty good when I was listening to it, but I found some problems that I wasn't really happy about. Especially the loose connections on all the collectors of some of those transistors. You get a high resistance in there, it's going to mess up your sound. And not only that, you could grenade your amplifier if one of those goes open. They weren't tight at all, and I don't know how they were making connection. There was a long list of problems I resolved on this. High resistance on these two switches, and high resistance on the speaker output switch. Got a noisy volume pot. We had damaged emitter resistor and the wrong value in one spot. Wrong fuses that were installed. Oh, the list goes on. So whatever I did to this should help it live a long life and sound good while it's doing it. So that's it for this one. Take care, and we'll see you on the next one. Thanks for watching.
Onion head hat, we are building a religion.